Hey there, it's Shahir. So about a year ago, I made a 52 ACT math skills video series where I spent over an hour going through all of the ACT math skills that you are almost guaranteed to see on the ACT math exam. A lot of students love that series, but it is a very long series. It takes a lot of time to get through and it's multiple parts and multiple videos. So I wanted to create a shorter guide that goes through a lot of the same information and that will give you exposure to all those skills, but do it in a short amount of time. I understand that a lot of students watching this might not have an hour, 2 hours to watch that video. You might be cramming, whatever the case may be. So this is a condensed, shortened version of that. You'll still get exposure to all the skills. You'll still see some examples. It's just that I'm not gonna go in depth and explain every little thing. If you do wanna see that video series, I have it linked below. I'll also put it in the card, and you can watch that if you like. The last thing I'll say before we get into the actual video, if you need any tutoring, any additional strategies, any resources, practice exams, free content, free tutoring even, check out our website linked below. We have free and paid resources, courses, things like that a lot of students have found really helpful and improved very quickly with. So you can use all that. A lot of it is free and it'll help you improve really quickly on the ACT math exam. So without further ado, I'm gonna get into the video. I will say that I go through the skills pretty quickly because I'm trying to get through 52 math skills within 10 to 15 minutes. So if you feel like I'm going fast, it's on purpose. It's because I'm not trying to make this into a 2 hour long video. All right, I'll see you on the other side. Skill number one is midpoint. This one's pretty straightforward. If I give you a series of points, all you have to do is find the average of the x values and the average of the y values, put a comma between them, and that is your midpoint. Pretty straightforward. Proportions, this is where you have to set up a fraction to solve for something. So the classic example is 18 is to 12x as 5 is to something. So you do 18 over 12x equals 5 over something, and that's something right there. You just solve for the question mark and get your answer. Transformations is the number 3 skill. This is gonna be pretty complex to talk about in this video because it takes a lot of time to actually understand it, but this is something that you should have practice with. If you've taken Algebra 2 or Pre-Calc, you should know how to do this. Absolute value expression simplification. Everyone knows that the absolute value of something is just the positive version of that number. So simplifying expressions like this, you just take it step by step, and then you finally get your final answer. So that's something that you should be able to do as well. Slope, as long as you can remember this formula, or that, if I give you a line and I drew it like this, you should be able to find the rise divided by the run between 2 points to get the slope of the line. This equation does the exact same thing. Moving on to Pythagorean theorem, aka distance formula. Distance formula is actually kind of the same thing as this, but this formula applies to all right triangles of this form where you have A, B, and C. C is your hypotenuse. You can use this formula to solve for any of those 3 sides as long as you know 2 of them. Combinations. This is a classic combinations problem you should be able to do. If you're given 3 socks, 5 shoes, and 12 shirts, how many outfits can you make? You just multiply all of them together and you get some number. That is your answer. That's the general approach for most combinations problems. Some are a little bit more complex. I'm not going to get into that here. Scientific notation is pretty straightforward if it's multiplication or division. In this case, it is division. So what you would do is just divide these out and then divide these out. You should know how to divide exponents like this. That's a later skill, but this is something that you should be able to do. It's a little bit more complex for addition and subtraction. Substituting values into polynomials. So this is literally where you are given an equation and you're told, hey, plug this in and see what you get. And then you have to choose the right answer, which is just going to be whatever that number ends up equaling. So you should be able to do this. The main thing here is you don't want to make sign mistakes. Rational and irrational numbers. So what makes a rational number? It can be written as a fraction of whole numbers. So square root of 2 over 3 is not rational, but 2 over 3 is. For example, pi is not rational. E is not rational. I is not rational, but 2 over 9, for example, is. So those are just some examples you can think through. Word to algebra translation. So you will be asked to translate expressions like this into math terms. So x squared plus the cube root of y equals the product of 10 and x, the product of 10 and x. So I just did it. You should be able to do that. We have more practice problems for this on our website. Probability, so if I give you some, like the classic example is you have 10 marbles and they're all in a bag and 3 of them are red. So what's the probability of drawing a red marble? It's just going to be the number of red marbles. Like if we're looking for the probability of event A, which is red marbles, then it would just be the number of red marbles, number 3, divided by the total, which is just 10. And that's a 30% probability. So that's how you do those. There are more complex probability problems. This is just the more simple formula that you need to remember. Examples or applications of linear equations. So here's a classic problem. Gym A costs $3 a month for membership plus $20 for the original fee. Gym B is pretty similar. It's $4 a month plus $16 for the original membership. So when do they actually equal in cost? After what number of months do they have the same cost that they are equal at? So that's a classic problem. You will see a lot of that. Let's go up to finding sine, cosine, and tangent with visuals. So if I give you a right triangle like this, you should be able to find sine of B or cosine of A, things like that. Just remember, so, ga, toa, also cho, sha, cow. I have more videos that go over this thing here. If you don't know what that is, I recommend you watch our formulas videos where we go more in depth on that. We also have a lot of that in our courses. Analyzing frequency charts. This seems pretty straightforward, but what if I asked you, if I was to randomly draw a student from this class, what's the probability that the student scored over 120? So analyzing problems like this with this tally or with this frequency is kind of what you are being asked to do when you're analyzing frequency charts. Ordering fractions, you need to be able to order these. It's pretty straightforward. I would just plug each of these into your calculator, find the decimal equivalent, and then order the decimal equivalents of these, and then turn them back into fractions. Pretty straightforward. Least common multiple and greatest common factor. Classic problem is this. There are many different ways to do it. I don't have the time to go through it here, but this is something that we need to be able to do on the ACT exam. I could also ask you to find the greatest common factor of this, which is just, in this case, it would just be the largest number that all of these are divisible by. I think it's 2 probably. Complex numbers. So this is the main thing that you need to remember. I squared is equal to -1, aka I is equal to square root of -1. And you need to, when you are simplifying expressions with this number, you just use it as a variable until it's fully simplified. Then you plug this or this into your expression and you get the simplified form. So this is something that you need to be able to simplify. Properties of exponents. This is an image that I got on the internet that kind of summarizes it. I'm not going to go through all these here, but this is something that you should be able to do. The rules towards the top are especially important, so definitely know how to do those, or use them, I should say. Matrix operations. So you should be able to multiply matrices. More so, you should also be able to add and subtract them, know how you can add and subtract them, and when you are not allowed to add and subtract them. There are different rules on that. I have gone over that in the 52 ACT Math Skills video series, so you can check that out if you want to learn a little bit more about that. We also have lots of stuff on our website for that as well. Polynomial arithmetic. So this is where you are adding and subtracting polynomials like this. So it's all about sign mistakes here. You need to avoid, making mistakes with your negatives and positives. Another thing that you'll be asked to do is FOIL. First, outer, inner, last. So you multiply 3 by 2x, then 3 by -4, then x by 2x, then x by -4. You get some answer, so you should be able to do that. Finding slope of a line and parallel and perpendicular lines. So if I give you an equation like this, you should be able to calculate the slope by rearranging the equation into, y equals mx plus b. Then the answer is literally staring at you. You should also be able to find the slope of a perpendicular line. So if I give you a line that has a slope of 3/2, the perpendicular would just be the negative reciprocal. So you flip the fraction and then you do a negative version of that, okay? Solve equations in the form this right here. This is kind of straightforward. If I give you this equation, you need to solve for x. Not too much to add there. It's just arithmetic. Solving and graphing inequalities. So if I told you to graph this right here, how do you simplify it and how do you actually graph it? You would have to graph it on the number line. So you'd have to plot like 11, maybe 12 or something. And you have like a dark circle arrow that way, a hollow circle arrow that way, something like that. I'm not saying this is the answer by no means. I just threw something on here, but this is something you need to be able to do. There are going to be questions where you're given answer options that look just like this, and you have to be able to distinguish which one's right and which one's wrong. Absolute value inequalities. Similar to above, except now you have an absolute value in there. Usually there's going to be two solutions to this. One of them is just going to be where you take away the absolute value signs, and the other is going to be where you take away the absolute value signs, you flip the absolute value sign, and then make the original contents of the absolute value sign negative. I'd say that double check me on that because I'm kind of rusty on it, but that's usually what you're going to have to do, and you'll end up getting two different solutions. And then you'll have to graph that on the number line. Graphing inequalities in the coordinate plane. So you have to graph the following, for example, the following system. You'll have to first graph this inequality and then graph this one. There's different ways to graph these. So this is where you're actually going to like do the, let's say the line looks like this and the circle looks like this. You have to shade something like this or maybe something like that in order to get your answer. So this is where you have to shade the XY coordinate axis. Okay, moving on. Converting units. So can you convert from yards to meters or yards to feet or inches to centimeters or things like that? Usually most of the conversions you'll know in the back of your head, like, okay, 1 mile equals 5280 feet. They're not going to ask you about centimeters to micrometers, because most students don't know that, but if it's something weird, they'll give it to you, like they'll give you a hint, but usually they'll expect you to know like 1 mile, 5,280 feet. They're not going to expect you, I've never seen them say 1 meter equals how many feet, because people don't usually remember that off the top of their head. There are 2 types of sequences that you need to remember. Arithmetic is where you have a common difference. So an arithmetic sequence, for example, could be 1, 4, 7, 10. You see that it goes up plus 3 every time. A geometric is where you have a common ratio, which is r. So that's an example could be 1, 2, 4, 8, 16. You see that it's times 2 each time. It could be decreasing, so you could go in this direction too, like 16, 8, 4, 2. Same thing in this case. You just need to remember these equations and how to use them. I'm not going to get into the details of that right now. Finding domain, range, and common and asymptotes. So what are asymptotes? It's basically, is there any value of this equation that makes the denominator equal to 0? Because you can never divide by 0, right? This is impossible. So there are going to be those points that make the denominator 0, those x values, those are called asymptotes, and the equation can never equal those x values. So you need to find those by just solving this bottom equation for 0 and seeing what you get for x. There's also a factoring component to this. You need to make sure that the equation is fully simplified before you start solving the denominator for x when it's equal to 0. Identifying characteristics of graphs. So can you take a graph and identify period, amplitude, slope, y-intercept, mid, and max value? You should be able to identify these. Period equals 2 pi over b. If you're given an equation like y equals a sine b x, a is your amplitude, b is, that's how that's related to period. These other things I've kind of already mentioned a little bit, so you should be able to identify those. Solving problems in context of money. This could be really any skill on the ACT exam, but it'll be about money, so it'll just be like a word problem about money. Not really a specific skill, but that is on the official list of skills. Descriptive statistics with frequency counts. So this probably looks familiar because I used the same image in another description like 5 minutes ago, but descriptive statistics refers to, all right, let's say instead of finding probability, let's have you find the mean, or let's have you find the mode or the median of this set of numbers. And you're not finding the median or mode of this set of numbers, you're finding which of these is your median and mode using these frequency counts. So that's kind of what you'll have to do here. It's just another way that they test you on frequency counts. So this is the same type of thing, except now it's for a list of numbers. So a classic example is the mean of a set of 6 numbers is 6. A new number will be added to the set of 6 numbers to make it 7 numbers now. What number must be added to make the new mean 100? It's kind of a wacky problem, but modifying a mean is something that you will be asked about. If you take the ACT math at least a couple times, you'll see this at least a couple times. Area and circumference of a circle. Area is pi r squared. Circumference is 2 pi r or pi times d. And cylinder, this should be area, is just going to be area of circle times the height of the cylinder, aka this. You see that they look kind of similar. You're just multiplying by height for the volume, sorry, this isn't even this is volume of a cylinder. Sorry for the mix-up. Area and perimeter of polygons. So area of a square is length squared, area of a rectangle. I mean, you can remember these. For the trapezoid, just want to mention the B1 and B2 refers to the bases. So if this is B1, this is B2, this is your height, this is your area of the trapezoid. You basically just take the average of your B1 and B2. Locating points on the coordinate plane, so the point 1, 1 is rotated plus 90 degrees about 0, 0. The new point is what? So that would look like 1, 1 is right here, 0, 0 is right here, and I'm rotating plus 90 degrees. So I would go in this direction, 90 degrees. I get a new point right here. It would end up being negative 1, 1. How exactly to do that? That's kind of what this skill is all about. Circle equations and inequalities. So this is the parent circle equation that you need to remember. The main thing is that h comma k is your center of the circle and r is your radius. So x plus 3 squared plus y minus 1 squared equals 10 has a radius equals square root of 10, and the center is negative 3 comma 1, okay? Deriving geometric information about a shape. So a cube has a surface area of 12. What's the volume of the cube? You need to be able to derive essentially the surface area and how that's related to the side lengths and the volume of a cube. These formulas like volume of a cube is just L to the third. You have to be able to remember that. And then surface area, I mean, you kind of know what a cube looks like. You should be able to find the surface area knowing that all the sides are just squares. That's kind of what these problems are asking you to do. Reverse engineer a cube in a way. Matching trig functions with their graphs. So Which of the following graphs has a period of 2 pi and an amplitude of 12? If I give you a trigonometric graph that looks like this, and I give you some points like 2 pi, I don't know, I'm just making things up, you need to be able to identify the period and amplitude. And there are skills behind, doing that and doing it properly. Logarithms. So if I give you an equation in this form, like 2 to the x equals 9, how do you solve for x? It's kind of weird, but using your calculator, you can just plug this in to solve for x. In this case, it would be log of 9, I believe, divided by log of 2. That would give you some number where that's correct. Unit circle geometry. The unit circle, maybe I should draw this out. The main thing you need to remember is that you have these 4 points, 0, 1, 1, 0, negative 1, 0, and you have 0, negative 1. And you also have A, S, T, C. So this is where all three, sine, cosine, tangent, are all positive. This quadrant, only sine is positive. This one, only tangent is positive. This one, only C is positive, cosine. If that didn't make any sense, watch the 52 math skills video, or again, we go over this on our website more in depth. Otherwise, you can ditch the unit circle and forget all about it and just memorize these special triangles, the 30, 60, 90, which is this one, and the 45, 45, 90, which is this one. Just set H and K equal to 1. So this is just 1. This is just 1. These ratios will always be true. So there you go. Matching linear equations with their graphs. So what is this all about? Which of the following graphs has a slope of 4/7 and a y-intercept of 12? So it'll basically give you multiple graphs with like different slopes and different this and that. And they'll ask you which one has these characteristics. So you have to be able to identify that. Again, rise over run, plugging in points to your equation to see what the slope is, that kind of thing. Finding lines of symmetry. So this is all about it's just something that with practice, but there's only so many shapes. So as long as you're able to do this for at least a few shapes, you should be good. This is an image that I found on the internet from Online Math Learning, I believe it is. Really, you just have to memorize a few shapes, how many lines of symmetry there are. But it's pretty intuitive. You're just treating lines of symmetry as a mirror line in a way. Similar and special right triangles. What is this all about? So you used to remember this. These are called special right triangles. Another common one is the 3, 4, 5 triangle. So 3, 4, 5. That's not drawn to scale. And again, you can, when I say similar triangles, another version of this is the 6, 8, 10, or you could do the 9, 12, 15, essentially just multiplying each of these values in the triangle by any number. And that's how you get similar triangles. So like this side could be 10, this could be 8, this could be 6, and this one could be 3, this could be 4, this could be 5. These two triangles are similar because the ratios of corresponding sides are the same. It's just times 2 essentially. Moving on, we also have using Venn diagrams with counting. So this is a classic problem I've seen a number of times. 2 radio towers are 100 miles apart. One has a service range of 40 miles, the other has a service range of 80 miles. So how much overlap is there? The answer is not 40, so don't get confused. But like drawing this out will help you. There's also some tricks that you can use, like I'm not going to get into it because this problem is a bit complex, but you should be able to solve something like this, and we help students, like I said, with that on our website. Finding composite functions. What's a composite? So if I give you two functions like this, if you plug g of f of x, what does that become? So when I say g of f of x, that's literally where you take f of x and plug it in for x in the g equation. So that would end up being 4. That would end up being 4 times 3x plus 2 squared plus 3 times 3x plus 2 plus 2. And that is what that is. You just simplify that, get your answer. Finding unknown angle measures in geometric figures. So if I asked you to find h, how would you do it? You have to use some properties that I'm not going to get into here. There's a lot of angle properties like alternate exterior angles, opposite angles, triangle, like what they add up to, the interior angle measures, things like that I'm not going to get into, but you should be able to solve something like this by first finding this angle, then using the fact that the inner angles of a triangle add up to 180. So this angle plus this equal 180. Conditional and joint probability. So what is joint probability? This is an example. 36 students are in a class. 1/3 of them like candy, and a third of that 1/3 like coffee as well. So how many people like coffee and candy? Well, it would just be 36 times 1/3 times 1/3. That should be 4. How many students do not like both? So that would just be the students that are not these 4, which would be 32. Okay, so questions like that you should be able to answer just using basic probability. Read relevant data in a figure and use it in computation. So problems 15. So if they give you a problem where it says, hey, here's a diagram, the next 3 problems refer to this specific diagram, then that's kind of what this is all about. that's basically it. Those are the 52 math skills in a nutshell. I know I didn't really teach any of them, but I gave you some examples and I kind of gave you a little bit at least on what you need to know and, a bit of an introduction on how to do these. So I hope that was helpful. If you need any help with learning these skills, we have lots of tutoring resources, additional practice problems. We have a skill study guide. We have skill videos that actually teach every one of these skills, all on our website that is linked somewhere on the screen or in the description below, or both. So I recommend you check that out. A lot of students have found it helpful, and our courses are very affordable. You can access all of our content for just $40. So that's it for me. Best of luck prepping. If you have any more questions about how to use our programs, or if you want us to make a specific video about a certain idea, then let us know. We'll probably do it because we love hearing your guys' feedback and ideas. That's it for me. Best of luck prepping, and I'll talk to you guys in the next one. Bye.